I'm going to begin by drawing a sketch of this triangle. We've got a 30-degree angle between PR and PQ. We've got a length of 2, and I've got an opposite length of P. And this question really is about the SSA condition in triangles. This does not imply congruency in general, but we're looking for values of P that is going to guarantee congruency. You only get one triangle. For example, the one I've drawn here, okay, this is one such triangle, but I could instead have P going this way. Same amount, but I would still get a length of 2, an angle of 30, a length of P. I'd get a different triangle. So this value of P, for example, would not give me a unique length of PQ because, as you saw, I could have two different lengths. And it's really all about the angle Q, which I'm now going to show you. We can use the sine rule and write down that P divided by sine 30 is equal to 2 divided by sine Q. Now sine 30 is actually a half. So if I times through by that, I'm going to get P equal to 1 over sine Q. And that's the crucial idea behind my construction over there, because two different values of Q can give you the same value of sine Q. If we look at the sine graph just between 0 and 180, this angle will give me the same value of sine as this angle. For example, if Q was equal to 70, for example, 70, that would work. And then here's my line of symmetry at 90. I could instead have Q equal to 110, and that would also give me the same value of sine. So that wouldn't give me a unique answer. So how am I going to get unique answer? Well, it comes back to this 30 degrees actually, because if Q, for example, was equal to 10 degrees, then my other answer would be 170, because it's always 180 minus x. And this triangle wouldn't exist. I just can't have it because the 30 plus 170 takes me beyond 180. So actually, I'm looking for this zone here. So just to summarize, we will get a unique triangle when P is in this range, because the obtuse angle also that gives the same sine value will not lead to a physical triangle. Therefore, we need 0 to be less than Q, which is then less than or equal to 30. We'll include 30 in it because then the obtuse angle will be 150, and you get 30, 150, and 0. You wouldn't get a triangle that way either. Now, there is one other case we need to think about, and it's right at the peak, because in that case, you get 90, and 180 minus 90 is 90. That would also give us one triangle. That is so easy to miss, and I've got to admit, I missed it. So that's it. If I got 60, for example, then I'd get 120 as another solution. I wouldn't have a unique triangle. It has to be between this range or 90. Now I'm going to find out what sine q is by just taking sine of both. Sine is an increasing function for this interval. We can do that, no problem. So 0 is less than sine q, which is less than or equal to a half. Or sine q equals 1. Replace that by 1 over p. Therefore, p is either equal to 1, or for it to be between 0 and a half, it's going to have to be greater or equal to 2. And that is our solution set. Now have a look at the work solutions. They do it in a slightly different way, but I like this approach, sticking with it. So our answer is going to be E. Well done.